GeoGebra.
So, what is GeoGebra? GeoGebra is an interactive geometry, algebra, statistics, and calculus application intended for learning and teaching mathematics and science from primary school to university level. GeoGebra is an outstanding technology tool that improves mathematics education. It is a quality 21st century transformative application that enhances and supplements traditionally memorization-based study of geometry. Its creator is Marcus Hohenwarter, started the project in 2001 as part of his thesis at the University of Salzburg, continuing it to Florida Atlantic University from 2006 to 2008, and now at the University of Linz together with the help of open source developers and translators all over the world.
Interactive GeoGebra, algebra, statistics, and calculus. GeoGebra is an interactive mathematics software program for learning and teaching mathematics and science from primary school up to university level. Constructions can be made with points, vectors, segments, lines, polygons, conic sections, inequalities, implicit polynomials, and functions. GeoGebra has the ability to use variables for numbers, vectors, and points, find derivatives and integrals of functions, and has full complement of commands like root or extreme move. Teachers and students can use GeoGebra to make conjectures and to understand how to prove geometric theorems. So the main features of GeoGebra are it is an interactive geometry environment, and it can create a 2D and a 3D. It has a built-in spreadsheet, built-in CAS, built-in statistics and calculus tools, and it allows scripting. GeoGebra material platforms. GeoGebra materials can also be exported in several formats, including as static images or as animated GIF. SVG vector images can be further edited using third-party software, e.g. Inkscape. EMF vector formats can be directly imported in several Office applications. There are also options for exporting to the system, clipboard, PNG, PDF, EPS. GeoGebra can also create code that can be used inside latex files through its PS tricks, VGF or TICS, and asymptote exports options.
Examples and application of GeoGebra. World longest ski jump. On 18th of March 2017, Robert Johansson set a new world record with 252 meters only 30 minutes later. The great Stephen Kraft set another world record to an astonishing 253.5 meters. Johan Herman Evensen, who has the former holder of the world record for the longest ski jump at 246.5 meters, is the side commentator for the Norwegian TV.
Example is Galileo's inclined plane experiment. Galileo performed his free-fall experiments with the inclined plane in 1603 and published them in his discourses on two new sciences on 1638. The setup consists of a piece of wooden molding or scantling about 12 cubits long, half a cubit wide, and 3-finger breadth stick with a channel cut in it, and the bronze ball rolling down. The running time was measured independent on the inclination of the plane, and so the law of the retarded free fall could be determined. Inquiry-based learning environments could comprise the questions of time measurement and the derivation of the respective formula.
Here are some sources.
GeoGebra. Thank you for watching. Pakiring na rin yung bell tapos subscribe.
Math used to be hard to understand, but our teacher Mr. Cobb showed us this cool program called GeoGebra. It makes complicated math problems more manageable, especially when we work with 3D geometry. And the Intel RealSense 3D cameras in our new Acer laptops have totally changed the way we interact and learn math in 3D. With GeoGebra and Intel RealSense, we can explore the geometry of real objects, like the shapes that make up our football, and even create new ones. I've learned that there are complex shapes and equations everywhere, but using GeoGebra and the new Intel RealSense computers, we can understand them better. It even makes tricky things like geometry, algebra and graphing much easier too, and gives us a much better view of the world around us. We can use GeoGebra on loads of different devices, so it doesn't matter where we are. With GeoGebra and Intel RealSense, we all look at math in a completely different way.
We knew there was demand for chemistry and math.
We've looked around for really nice math applications that would lend itself well to the 3D platform of ZSpace. GeoGebra really brings that solid math application to the platform.
GeoGebra is a dynamic mathematics software that supports teaching and learning from kindergarten through grade 12 and all the way on through tertiary education.
What ZSpace and GeoGebra allows the user to do is look around objects, and really now your mind starts to think that these objects are out in front of you.
When you've got a ZSpace unit with GeoGebra integrated directly in, where you can actually do three-dimensional mathematics in three-dimensional space, teachers and students say, wow. And what we've got now is a couple of great GeoGebra add-ins into Microsoft PowerPoint, OneNote, and Microsoft Word.
The collaborative effort with GeoGebra is heavily based on the Office 365 platform. We are based in California, however, GeoGebra is based in Europe.
Skype is very helpful because we are so far away from each other, and facing people as if they were at the same place. It's a very nice solution for us.
We also use Office 365 OneNote for our note-taking and for our collaborative documentation.
You know, working with the ZSpace guys, using Office 365 and OneNote and sharing our ideas back and forth, it's been integral. We just couldn't do it without it.
Office 365 is becoming integrated with the tools that we provide to the schools. There is so much potential for students to share, to collaborate, and to take on much more than they could in the past through the combination of ZSpace, Office 365, and GeoGebra.
Currently what their front page looks like. Now you'll notice right away that there's three primary sections that they divide their website in. They have materials, which is a collection of pre-made web pages that other individuals have put together that you can freely access. Your Start GeoGebra, which is how you would launch GeoGebra within a web browser, and then your downloads. Since we're deciding that we want to install this on a Windows machine, we're going to go ahead and click on Downloads. Now, once the download page comes up, you'll notice that you have the options to download for a tablet. You can also download for any of your desktop environments, and then you also have the Android phone app here as well. Because we're aiming for Windows, when we click this and we're using Google Chrome, you'll notice that it downloads into your download bar. What I'm going to do, since this is taking a little bit longer than it normally would, is I'm going to pause, and when it's finished downloading, we'll resume this tutorial. Now that my download is complete, I'm just going to click on the GeoGebra executable right here, and you'll notice that you might get a message saying, because this was downloaded from the internet, do you want to run it? Just go ahead and click yes. And what this will do is it'll walk you through the installation wizard, where you'll just click next, agree to any of the end user agreements. You're welcome to read this if you are interested in finding out what all the specific details are. And I usually just leave it at the standard installation and click install. Because I already have GeoGebra installed on my computer, I'm going to hit cancel at this time. But this takes you through those steps that you need in order to download the Windows executable. If for any reason you're not able to install the Windows executable, there's also an option right here for more GeoGebra downloads. When you go into this particular area of the website, there's another option, which is to download what's called a portable version. So right here you can see that you have the GeoGebra portable for Windows, which you can install on a USB drive or a memory stick. And the difference is that when you download this, what's going to happen is it's actually going to download as a zip file. So when this zip file is completely downloaded, you'll have to extract it, and once it's extracted, you'll be able to run GeoGebra from the folder that's within this particular zip file.
I'm just going to run through a quick construction here using some of the tools. So I'll go with the polygon. And then I will use the perpendicular bisector. I'm pointing at the sides in turn. And then I will choose a point of intersection between those three. Now we'll choose a circle with center through a point. So centered on D through the point C, for example. Changing back into pointer mode, we can now manipulate and see where the center, the circumcenter of that circle will be. Now we can go over to the menu and we have the option to save this file within GeoGebra. Of course, working on the Clever Touch, we can also call up our annotation widget and say, let's have a look at the location of that center in relation to the triangle itself. And we have the option then of capturing that. And when we're finished the activity, let's just close out our annotations and let's just revert back to our home screen.
Good morning, class. Welcome to the demonstration on how to make basic shapes using GeoGebra. Step 1, you are going to open GeoGebra and it's waiting. It's going to hide my face here in a second, but that's okay. Now go to full screen, and what you should notice is two windows. First, the graphics window, which is here. We will be doing building our shapes in here, and to the left is the algebra window. Our shapes and the points will be listed later on here. So let's start with changing the view a little bit. Go look at this arrow to the left of graphics. Click on it once. With these buttons we have the option to show or hide, which is what I want. Our axes, we can also show or hide. I want to show our grid. Let's start with a rectangle. Here is the polygon tool. You click, the polygon tool is selected. To make a rectangle, I need 4 points. Now it kind of snaps into place when the intersections are perpendicular. So, and you click the 4th time to close your rectangle, and there we have a rectangle. Now for a square. A square is a regular polygon, so we click on the regular polygon tool. Here you just need to specify one segment, and then you are asked how many vertices you want. A square has 4 vertices, so we want 4. You click OK. If you wanted to do a regular pentagon, you use the same tool. The same tool is still highlighted, but we'll just do it again. So a regular pentagon, so you specify this segment, and let's say we want 5 vertices. Since we want the pentagon, you click OK, and there we have a regular pentagon. To do a triangle, use the same tool. Let's do a non-equilateral triangle. So you just do 1 point, 2 points, 3 points. Close the triangle by clicking on the original point, and there you have a triangle. Last, to do a circle, there are 2 tools which will be useful to you. This top one, which is circle with center through point, and the second one, which is circle with center and radius. Let's do this one first. This one, you specify the center, and then how long do you want your radius? Let's say we want a radius of 2. Enter 2, click OK, and there is a circle with radius 2. Let's go back to the top, and let's do the first tool, this time circle with center through point. Now you click once, that is your center, and then you have control of how big or how small you want your circle. Click, and there you have another circle. Before I let you go, click on this tool, and this is how you move shapes around once they are in place. Now this, we had a rectangle, we can move that around as we wish. Now notice this was specified as a square, so it won't let us change the nature of a shape. It will always be a square, but we can change the orientation, and the size. The same with the pentagon. Notice the blue points are the points you need to choose in order to manipulate the pentagon. The triangle, we did not specify an equilateral or isosceles triangle, so we can move our triangle around as we like. Now, the circle, this one's a little bit harder to manipulate. You can double click and go to Object Properties, and here to change the radius, let's see, Advanced, algebra, I'm not sure how you would change the radius of this circle, to be quite honest. So I would just go back and make a new circle if I wanted a circle that was a different size. This one, however, you can change the size by clicking on the point that's on the circle, and then you increase or decrease the size of your circle by manipulating the mouse. Now, before I let you go, I know I'm kind of dragging this out, look to the left and notice here we have different points. All our points and their XY coordinates are specified. Also, these polygons, polygon 2, which you can either highlight it or hide it or show it, hide it or show it. Same thing here, hide it, show it, hide it, show it. If you go to the conics, a conic, that's a fancy name for a circle. You can hide it, show it, hide it, show it. Same thing here. And these numbers to the right of your shapes, that is the area, actually, that is the area of your shape. And so, for example, polygon 2, it has an area of 9, which makes sense because our length is 3 units, our height is 3 units, 3 times 3 is 9, so just be aware of what information is available to you here. So this ends our demonstration on how to make basic shapes. More videos to come.